Imagine you run a tech company. You hire one AI assistant to help with coding. It writes functions, fixes bugs, and explains logic. Everything works smoothly. Then someone on your team says, why use one AI when we could have used five AIs working together? So you build a system like this: Planner AI, Research AI, Coding AI, Testing AI, and Reviewer AI. It sounds like a dream engineering team. But soon you notice something strange. Instead of getting faster, your system becomes slower, more expensive, and sometimes chaotic. Why? Because what you just built is not just an AI system anymore. You accidentally build a distributed system. And distributed systems comes with a lot of hidden problems. Back in 1975, computer scientist Frederick P. Brooks wrote a famous book called The Mythical Man Month. In it, he made a simple observation: adding manpower to a late software project makes it later. Why? Because every new worker adds communication overhead. If you have one developer, no coordination is required. If you have three developers, multiple discussions happen. If you have 10 developers, there are meetings everywhere. Soon people spend more time talking about work than doing work. The same thing now happens with AI agent. Originally, AI systems worked like this. One big model handled everything. But these models have limits: limited context windows, memory constraints, and reasoning mistakes. So engineers tried a new idea: split the work across multiple AI agents. Each agent specializes in a role. This is similar to how companies organize teams. But here's the catch: when many agents start working together, the system behaves like a cluster of computers. And clusters come with classic distributed system problem. Think of each AI agent like a computer node in a server cluster. They share several important traits. First, independence. Each agent has its own limited context window. It does not know everything happening in the system. One agent might use GPT-5, Gemini 3 Flash, Claude Sonnet 4.6. Each one sees only part of the world, just like servers in a distributed system. Second, communication. Servers communicate using network packets. AI agents communicate using messages and prompts, but there's no shared memory. Every piece of information must be written into a prompt, sent to another agent, interpreted again. That process is slow and error prone. Third, concurrency. Multiple agents often run at the same time. This sounds great in theory, but it creates synchronization problems. If two agents act on old information, they can start working toward different goals. Engineers call this a split brain problem. Fourth, fallibility. AI agents make mistakes. They can hallucinate, stall, misinterpret instruction. In distributed systems, this type of failure is called Byzantine fault. The system must assume some nodes may behave incorrectly. And then there is a big myth. Many people assume that adding agents will automatically make a system faster. But computer science already has a rule about this. It's called Amdahl's law. It says the speed of a system is limited by the parts that cannot be parallelized. Imagine cooking dinner. So the steps of cooking dinner is: chop vegetables, boil water, and cook pasta. You can hire 10 chefs, but boiling water still takes the same time. The same happens with AI tasks. If tasks depend on each other, agent must wait their turn. So more agents don't help much. Another scaling problem comes from something called crosstalk. As the number of agents increases, communication grows rapidly. Every agent must read messages from other agents. With 5 agents, the conversation history becomes huge. Agents start spending most of the time reading each other's messages instead of solving the problem. Now, there are two common ways we can organize AI agent teams. First, centralized system. One orchestrator can assign tasks. Example: agent A write functions, agent B write test, and agent C reviews the code. It gives you less communication overhead and more consistent result. But if one agent becomes slow, everyone waits. This is called the straggler problem. Second, decentralized system. Agents choose tasks themselves. They might say, I will take task number 3. This sounds flexible, but something surprising happens. Agents start negotiating. They debate who should do what, whether a task is complete, what the next step should be. The result: lots of talking, little progress. In experiment, decentralized teams were actually slower than a single agent. When multiple agents work on the same project, new problems appear. Two agents edit the same file, one change overwrites the other, progress disappears. An agent reads outdated information, it believes a task is not finished, so it writes work that was already completed. One agent tries to implement variance before another agent finishes mean. The system breaks. Another hidden cost is token usage. When agents communicate, every message consumes tokens. Sometimes agents even start being polite. For example, one experiment saw agents sending messages like, looks like Dev 1 is working on the final task. I will stand by and cheer them on. Nice sentiment, but every cheer costs tokens and money. In one case with Gemini, the system used 15 times more tokens while actually running slower. The straggler problem. Distributed systems also suffer from slow workers. Maybe one API request takes longer or one reasoning step becomes complicated. If the system is centralized, everyone waits. If the system is decentralized, another agent may jump in. So decentralized systems are less efficient but more resilient. When researchers measured performance, they found something shocking. Sometimes teams of agents were more expensive, slower, and less reliable. For example, 3 agents, the speed was slower and it cost 15 times more tokens. With 5 agents, the speed was slightly faster and there was small token increase. With 5 agent of serial tasking, the speed was slower and 3 times more token usage. This means multi-agent systems only work well when tasks are highly parallel. How we should design AI teams? The solution is not better prompts. The solution is better system design. Future AI systems should borrow ideas from distributed computing, consensus protocols like Paxos or RAF, load balancing algorithms, task schedulers, shared state management. Instead of agent negotiating in natural language, an orchestrator should assign tasks efficiently. The big lesson. Many AI engineers treat multi-agent systems like role-playing games. Manager agent, developer agent, reviewer agent. But that's just a metaphor. In reality, these systems follow strict mathematical rules for distributed computing. If we ignore those rules, we get chaos, wasted tokens, and slower system. If we respect them, we can build powerful AI clusters. Now, before building a multi-agent system, you should ask how much of this task can actually run in parallel. If the answer is less than 50%, you are usually better off using one powerful agent like Cloud Sonnet 4.6. Sometimes the smartest AI team is simply one really good brain instead of 5 confused ones.